Hi, I am Pascal, and I represent a company called ChilliCream. We are very active in the open source space and are known for a GraphQL server called Hot Chocolate. The ones who follow the GraphQL ecosystem closely may also know us from GraphQL Fusion, which is a community effort to get an open source federated GraphQL specification, which is MIT and under the GraphQL Foundation. We also provide GraphQL tooling, namely Banana Cake Pop, which you can use to manage your gateways, to monitor your subgraphs, and to also get insights on trace level of any of your GraphQL operations to really see what's going on inside your GraphQL request. Now that you know me and you know what we do, let's talk about how you not break your GraphQL client. The GraphQL schema is probably the most important artifact of your GraphQL API, and it doesn't matter how you define the GraphQL schema. It could be code first, it could be schema first. In the end, every GraphQL server has a schema, and this is how a schema looks like. It defines the contract between the client and the server. And in a modern API, especially when you use GraphQL, you usually have more than one consumer of your application. You have maybe a watch app, a mobile app, or even a coffee machine. It's the nature of such schemas to evolve and change over time as you add functionality to your app and you improve your application, which means that the contract between the client and the server changes. So it would be very bad if this contract breaks. The problem is it's very easy to break this contract. Even when you have good intentions and you want to fix this typo, you may accidentally break a client. I have a little demo prepared that shows how easy you can break a GraphQL server. For this, I have created this example app, this to-do app, which definitely didn't take as long as the whole presentation to build. And we have just got new requirements for this app. Now with the whole OpenAI hype, we also want to create AI to-dos, and we're going to implement this now. For this, we go to the editor, and we just add in this to-do app a new to-do, get AI to-do. And AI to-dos are a bit special because AI to-dos do not have an offer because they are generated, which means that we have to make the offer, the created by, nullable. And we will also do this. And now let's save the application. This will restart the server. And when we go back to our app and we refresh the page, then we see that we just broken our application. So now, why is that? When we go back to the code and we have a look at the client code, then we see that in this React component, we use a fragment, and there we require created by. And with GraphQL code generation, typings generation, we know that created by is always there and will never be null. Now the problem is that because AI to-dos don't have an offer, created by in this case will be null. And we didn't realize that we break our client application like this just with a backend change that we published to our service. Now, the easiest way to work around this problem in the backend is when we create snapshot tests. And snapshot tests are basically just an in-memory GraphQL server that you start up with the same configuration than in the application. Then you print the schema and you create the snapshot of the schema that you always compare against. And when we run this test, let's run the test. When we run this test, we immediately see, let's close this window quickly, that we have a change in the schema definition from our app. To-do has a change, and we see that created by now is nullable where it was non-nullable before. And with this, we know before we deploy that the schema has changed and the application breaks. Even if you don't use any special services or applications for schema validation, it's always good to have a schema snapshot because it makes it really easy in pull request reviews to see what changed in this pull request on a schema level. But there are a few problems with schema snapshots. Let's go back to the application. The first problem is that it doesn't scale. And you don't even have to have a big team or a big organization to run into these issues. Even if you have a one-man project, it could be that your schema diff is huge after a big refactoring. The second problem is that it's really difficult to share the knowledge in the whole team. You either have a few selected developers that have to review all pull requests, or you have to distribute the knowledge across the whole company. And the biggest problem is that GraphQL changes are really complicated. It's really hard to get this right. If we look at the example before, you may thought that, well, this nullability change, that's something obvious that this breaks. But what about this? Is this a breaking change? When you add an enum member to enum? Well, it doesn't matter if you say yes or no, because you're kind of both right. Now, let's go through the different kinds of changes in the GraphQL API. The easiest thing are the non-breaking changes. A non-breaking change is when you add a field to a type, you add a whole new type, or you add an argument with a default value, or a nullable argument. And there are many more of these non-breaking changes. Then there's another category called the dangerous changes. And the enum member that we added in the example before is exactly this. It's a dangerous change. In this category, there's also interface implementation, or adding an interface implementation, adding a union member, and many more. Now, why are these dangerous? Well, in strongly typed clients like in Java, in C#, in Go, whatever, it could be that the client expects to be able to serialize a value that comes from the server. Meaning that if you only have foo and bar in an enum, and now you return bus from the server, what should you serialize it to? And for example, Relay also has a feature that you can enable, which is called future-proof enums, which basically generates always another member into the generated code that is for these non-serializable new enum types. But a lot of clients by default would just break. And then there are breaking changes. And these are the obvious ones when you remove any field, when you remove any argument, or even when you remove an executable directive. Because it could be that in a query there is an executable directive in there. So how can we do better than just snapshots? We use the schema registry. The schema registry helps you to manage your schema. So the schema snapshot that we have had before, we now just upload to the schema registry in the CI pipeline. The schema registry can then process the schema and can validate the schema based on the history and based on rules to see if there are any breaking, non-breaking, or dangerous changes, and can output a report. And this report can then be analyzed in the CI pipeline, and you can say, this is a good change, this is a not so good change. These schema registries, they enable you to validate really early in your development cycle if something went wrong. And with this, you can increase the velocity of development. So let's assume you have continuous integration, which has a pull request pipeline, which runs every time you create a pull request and have a new change in the pull request. And you have a release pipeline, which runs on deploy. Now, in the pull request pipeline, you basically, first thing you do is you get the schema snapshot, you validate the schema snapshot, and if the schema snapshot doesn't pass, then you just break. And in the release pipeline, you build first your application, you build the container, then you upload the schema to the schema registry. We do this in BCP with a tag, for example, the commit ID, or even some special version that that you specify. And then before you deploy an application to a specific stage, so for example, development or production, you publish it to this stage. So you uploaded the schema under version 1, then you publish version 1 to stage development, and if everything is good, you deploy your application. Now, each schema you upload to the registry will be stored. And as soon as you tag your application, a new schema file is uploaded to the schema history. All stages in your application, for example, development and production, have an active schema on their stage. And before you deploy an application to a specific stage, you basically switch the active schema over, for example, here to development, and then development has this new schema as the active schema. And all new schema changes will be validated against this new schema. Now you see that production might not have so many deployments as development, which means that you see that the schema diff can be different. In this example, you see that we only had one change on development, so everything was good. But when we wanted to release to production, we see that we actually have a breaking change in production that we first have to verify. For this, I also have a little demo. So let's go back to the code and open the helper here. There we go. What we do now is we accept, actually, let's go to BCP first. There we go. There we are. Now in BCP, in Banana Cake Pop, we have these two stages. We have development and we have production. And at the moment on development and on production is version 5 active. When we go to the changelog, let's go to the latest one quickly. Let's refresh. Let's go to the latest one quickly. We see that this is the latest schema. We see that this is the schema that we also have in our snapshot. Now we have had a change here in the snapshot, and we basically removed this, we changed the nullability of this field. And now let's upload this to the schema registry and simulate that we tagged our application, and we tag the application, 1 second, with version 11. Now you see, we specify the schema file that we uploaded, and we upload this to an API, this example API, under this tag. Now, let's try to publish this. So let's go here. There you go. Now we try to publish, and we change the active schema on development. We would do this before we release the application. And we see that the publish failed because there was a change on the type to do on the field created by, and you see that the type changed from string exclamation mark to string, which means that this is a nullability change. We can now force this change and do it anyway, just to show you the example. And now when we go here and refresh, we see that we have, 1 second, we have a new entry for version 11 that we just published to the stage development. And we see that we uploaded, we see the same breaking change that we have here. And in the schema diff, we see that this created by is now non-nullable. Good. And the question now is, are we safe? Well, the schema sometimes has to break, because we want to get rid of all fields. So what do we do when we want to break the schema? And how do we know which fields are still required if we break the schema? Well, the schema is just half the story. An application has usually more than one consumer, and each consumer has different queries, different requirements to the server. Now, each of these clients has its own version history. for example, here we have a mobile app in version 1.7 and we have a web app in version 2.2. Because, and the server, the mobile app, and the web app usually is maintained by different teams in a bigger company. And these versions, the latest versions, always have to work together. So let's say a mobile app in version 1.7 has to work with the schema 0.6 on development. And the web app in version 2.2 also has to work with the version 0.6 in development. Now, to make matters worse, there is also version history, which means that a mobile app usually is deployed in multiple versions, because there are people like me which do not regularly upgrade their phone apps, and then you have to maintain more versions which are in the past until they get out of support. So every time a new schema version is published, you basically have to verify the whole version history of each client against the new schema and see if it still works. And this is just when you have one stage. When you have a production stage, you have another schema which is active, which might have different client versions deployed. And you see that this gets really complicated really quickly, and it's really hard to get this right. But this is just how the real world works, right? So you have a mobile app in different versions. You will have more than one stage. You have a testing environment, you have a production environment, you maybe have a web browser, a phone app, or even a coffee machine, right? And we can solve this problem as well. But before we go into another demo, we have to think about how do we even know which fields a client needs from the server. There's a feature which most of the GraphQL clients support that's called persisted queries. Persisted queries is an export of every query that is in your application, and then the query is extracted and put into a JSON file. And the key of this JSON file, this 36ff whatever, is the hash of the query which is in there. Now, these query files, these persisted query JSONs, they can be sent to the schema registry as well. And now the schema registry knows all the queries, and it also knows the schema. This means that it can verify if all clients work with the schema when you deploy a new schema, or when you deploy a new client, if the client works with the schema. So you can check compatibility of everything. And let's try this out. So we go first quickly to the and go to clients. You see we have two clients here. There's no version active, otherwise this would be green. And let's have a look what we have in the code. In the code, we have a file called the persisted JSON. Where is it? And the persisted JSON contains all the queries, in this case one, of our application. And what we can do is we can, let's open script 3 quickly. We can upload, same as in the schema before we deploy a client version, a new version of our application. We basically just upload this client to the schema registry. And then let's first break the schema completely. You know the app requires created by, so let's remove the field. And actually, no, let's not do that. We can also just validate it. There we go. We have uploaded the client, and we now publish this client to the development stage. And when we go to BCP, we now see that there is a client version 7, which is active on development. We also see the operations and the document IDs that are there. We see the content of these documents. And when we go and break now the schema, like we have just done now, we remove created by, and we try to validate the schema upload. Validate. This would happen in the CI pipeline, right? And we validate this, then we will see that we have the same error message as before, or a similar one, that the field now is removed. And it will also tell us that there was an error because this query requires this field to be there. So this way we cannot remove a field which is still published in one of the clients. Good. Now these persisted queries, they have another nice side effect. They have, each query has a unique ID. And your mobile app or any other application just needs to know this ID when it makes a request to the server. Because the server can translate the hash of the document into the document body over the schema registry. The nice side effect now is that when you have a malicious attacker that sends a dangerous query to your server can just say, I don't accept queries with bodies, I only accept queries with query IDs, so persisted queries. And even if the attacker hashes the query and sends the hash, the server doesn't even know what to do with it because it cannot translate the hash back to the document, and the schema registry doesn't know this hash. This is a really easy way to secure your production environment while still having all the flexibility of GraphQL in development. You can still write your app normally, but as soon as you go to the production environment, your apps basically, your APIs lock down to the apps that you support. In the client registry, the flow is slightly different from what you see in the schema registry. You first upload it, then you publish it to a stage, then you deploy your application, your client app, your mobile app. And after you decommission the application, for example, version, 1 is now out of support, you unpublish it from the schema registry. And with this, all the queries are gone, the app is now unsupported, and you can now also break the schema. This really enables you to first deprecate the field and then phase out the field over a history of client versions. And then when all the client versions which still use the deprecated fields are out of support, you can safely remove the field. And you can also flag this as only break when there is a breaking change in a client. Good. So if I have to summarize everything which I said in this talk, then it's basically a schema and the client registry allow you to break your GraphQL schema without having regrets. Thank you for listening to this. And if you have any questions, you can reach out on the Bird app under Pascal Senn. And if you have no Bird app, you can also shoot me an email on pascal@chillicream.com.